Let's write the electronic configuration for a molecule that has, for several molecules that has a double bond in it. So we're gonna, first example is gonna be our aldehyde, formaldehyde. You do the same thing. You write your carbon, right? Remember that carbon is in group 4, so it has 4 valence electrons. You put the 4 electrons around it, right? Then we need to write oxygen. Oxygen is in group 6. So oxygen has 6 valence electrons. 1, 2, 3, 4, 5, 6, right? We have 2 hydrogens, right? And those 2 hydrogens, they're in front of the carbon. If we're going this way, they're in front of the carbon, so they're on the carbon, not on your oxygen. So let's put in the 2 of them. 1, you know your hydrogen bring its 1 valence electron, right? Hydrogen over here in group 1, and then hydrogen only has 1 electron. So we can now, there are no more atoms in here left for us to connect, right? So we draw a covalent bond, right? We draw a covalent bond here. Now, if you look at this molecule, let's see if our carbon has a full octet. It has 2, 4, 6, 7. That is not a full octet. Let's look at our oxygen. 2, 4, 6, 7. They both have 7. So this is what happens in a situation like this, right? This electron will move into here, into this bond on top of it, and this electron will move here, making a double bond. So the structure would be, write back your carbon. It's double bonded to the oxygen. Please keep your lone pairs. We didn't do anything with them. They're still there. Put them back, please. And then you put your hydrogens back. So all we did here, right? Here's the carbon. If you want to keep the structure looking like this. And then we drew a double bond O. And that would be Lewis dot structure for formaldehyde. Let's do another example. Let's do C2H4. C2H4. So we know carbon has its 4 electrons, and we have 2 carbons. Like I said, for most of these hydrocarbons, your carbons, they're bonded to each other. Now we have 4 hydrogens. These 4 hydrogens are not on the same carbon. There's one here. You couldn't put them on the same carbon either way. And there's one here, one here. So if we draw covalent bonds, right? Let's check if carbon has a full octet. 2, 4, 6, 7. Nope, that's not 8. 2, 4, 6, 7. Nope, that's not 8. So we do the same thing. We bring this one electron here and this 1 electron here. That's 2 electrons to make a double bond. So our structure is C double bond C, H, 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 right? Which is ethene. Let's do one last example. Let's say we have C2H2. Draw your 2 carbons. And like I say, most your hydrocarbons will have carbons bonded to each other, which is why I choose to draw the carbons right next to each other. Can't be hydrogens, right? Hydrogen will only need 1 bond, right? So you can't put the hydrogens beside each other and then try to put carbons in. No. Your molecules, your hydrocarbons in chemistry, in organic chemistry, is carbons bonded to each other with hydrogens on them, okay? So we put the carbons together. You connect your hydrogen. You put 1 hydrogen on each carbon. Make your covalent bond, right? And I'm going to erase. Oh, I didn't put 4. Here's your 4th electron. Make our bond. The same thing will happen because the carbon doesn't have a full octet, right? So in order to make it have a full octet, you put the electrons in towards the bond. So we make a double bond and then this one more bond. So this will make the double. This bond here will make it a triple bond. So we end up with H, C triple bond C, H. And that is how you write your Lewis dot structure for molecules that have a double bond in it or a triple bond. The goal is to make sure that the carbon, each atom has its full octet. So carbon here will have 2, 4, 6, 8. Happy, it has a full octet. Carbon 2, 4, 6, 8. Happy, it has a full octet.